Spearman's rank difference correlation coefficient. The formula is rho equals 1 minus 6 times summation of d squared over n times n squared minus 1, where the rho sign equals rho, n equals number of pairs, and d equals difference between two sets of ranks. What is Spearman rank correlation or Spearman's rho? The Spearman rank correlation coefficient is a non-parametric version of the Pearson correlation coefficient. Your data must be ordinal, interval, or ratio. Spearman's returns a value from -1 to 1, where +1 equals a perfect positive correlation between ranks, and -1 gives a perfect negative correlation between ranks, and 0 equals no correlation between ranks. It is also known as Spearman rho. Applicable when the set of scores that is available is in terms of rank, order, and when the set of scores is small or less than 30. When n is 10 or greater, testing the significance of rho can be computed using t-value, where t equals rho times square root of n minus 2 over 1 minus rho squared. I am now going to show you how to solve for rho and tu value. First, you have to rank the given from largest to smallest. Then, you have to subtract d1 from d2. And then after that, you have to square d. Then, get the summation of d squared. Now we have the summation of d squared. You can now solve for rho. First, we have to substitute the equation of rho with the numbers that we are given. And we can solve this step by step, but you can also solve this immediately on the calculator. Since the number of sets are less than 30, we can now solve for the t-value. Same thing here, substitute and solve, either step by step or immediately. We search for df, which is basically number of sets minus 2, and in this example our df is 9. Now that we have the df, we can now look for the tabulated value or tv. After getting tv, we compare to cv. If cv is higher than tv, then the null hypothesis is accepted, and that it shows no significant difference between the two sets. Here's the second example. We do the same thing as last time. We rank the largest to smallest. Then we subtract d1 with d2. Then we square d. And then we get the summation of d squared, where in this example is 149.5. Then we get to solve rho. We do the same thing as last time. We substitute the equation and then we solve, either by step or step, or with a calculator. As you can see, our solution for rho here is 1 minus 6 times 149.5, which is basically our summation of d squared, over 15 times 15 squared minus 1. Our rho here is 0.73. And then we solve for the t-value, because our number of sets are less than 30. We do the same thing here. We substitute again and then solve. You can do it step by step or with a calculator. But if you have to be safe and you have plenty of time, you can solve this step by step. Step by step method, you can see the mistakes you have done. Calculator may be fast, but then it doesn't show the correct answer. Here, our t-value is 3.85. Again, we solve for df, which is n minus 2. Our n here is 15. We subtract it by 2 to get 13. 13 is our df. We use this number to find our tabulated value of TV. Now, CV is greater than TV, so the HO is rejected. There is a significant difference between the height of the father and the height of the son. Here is the final example. The same thing as the other two examples. We rank them from largest to smallest. We subtract D2 from D1. We square D, then we get the summation of D. And in this example, the summation of D squared is 50.5. Then we solve for rho as usual. The equation we substituted. We solve it either step by step or with a calculator. And then we find rho. Here's a tip. If you have no time, use a calculator. But if you have plenty of time and want to have an exact answer, then do the step-by-step method, which is much safer compared to the calculator method. Our rho here is 0.58. Now we find the df again, which is n minus 2. Our n here is 9, so we subtract 2 from 9, which is 7. We find the TV, which is 1.89. We compare the CV to the TV, and if the CV is lesser than TV, the null hypothesis is accepted. There is no significant difference between x and y.